By 2050, we need to feed 10 billion people. But we also need to do so in a sustainable way. We need to make sure that the way in which we produce that food is net zero in terms of the carbon it emits. Now, the issue here is that meat consumption by this point is predicted to double. And as a lot of people know, this is one of the single biggest contributors to global warming, to carbon dioxide emissions. Globally, we face two big issues. How do we reduce our CO2? And how do we provide more food in a sustainable manner? But what if you could solve both problems at once? What if you could use carbon dioxide to create food? At Deep Branch, we convert carbon dioxide into protein. The technology is grounded in something that's relatively simple and something that humans have been doing for thousands of years, which is fermentation. So fermentation is the process of turning a substrate into a product via a microbe. Usually people might think of something like making wine, where you use the sugar in grapes to make alcohol using a yeast. In our process, instead of using a sugar like most fermentations use, we use carbon dioxide as a carbon source. Our microbes convert this into protein, and the protein we provide as a dry powder to animal feed producers. These feed producers combine it with other ingredients to make a complete compound feed, which they then sell to farmers who grow the animals that we eat. The founding Deep Branch team have got over 40 years experience developing and commercializing gas fermentation technologies, so this is our core tech. We've built a team with the necessary skill sets in terms of commercial relationship management, in terms of operational execution, that can take our technology out of the lab and into the real world. This is best illustrated with our ongoing partnership with Drax. Drax are the UK's largest producer of renewable electricity. However, they actually produce CO2 in their process, and that's where we come in. We utilize their CO2, and rather than it being something that's released into the atmosphere, we turn it into something that can be used to generate something sustainable, but also something valuable. The way it works at Drax is we have a containerized version of our technology.
We built it this way because we know that a lot of industries want to reduce their carbon footprints and improve their bottom line by valorizing off-gas rich in carbon dioxide or hydrogen, and these are the two gases that our process uses. To validate our technology, all that is required is three-phase electricity, enough room for a 20-foot shipping container, and access to a partner's industrial gas stream.
And on site with them, in real time, continuously, we produce protein. At Deep Branch, we put a heavy emphasis on partnership. We recognize that we're extremely good at what we do, but in order to fully commercialize our technology and make the impact that it needs to make, we need to have partners that are good at doing the things that we're not. In our ongoing partnership with the University of Nottingham's Synthetic Biology Research Centre, we utilize shared know-how to develop the core of our process. So we utilize their automated laboratories for strain development in order to direct our strains in a non-GMO manner to having a higher quality nutritional profile. From day one, we've been supported by BioCity, a UK-specific biotechnology investor that recognise the potential of early-stage companies and help them on the first steps of their commercialisation journey. In addition, we've also been supported by Innovate UK, the UK's innovation agency. Their grants are one of the most competitive means of non-dilutive funding that any company can get. One thing we often get asked is how we compete with soy on price. Now, the answer to this is that by beating soy protein on quality, we can command a higher price. And this is something you find across the board with all animal feed proteins. If you look at things like fish meal, the nutritional gold standard for aquaculture nutrition, the reason why it's so expensive for feed producers to buy is because it has all the right nutritional components that fish require to thrive. But so does Proton, our product. So by using Proton, you can have all the nutritional benefits without all the associated ecological problems of overfishing. What we learned from our partnership with Drax is that full-scale implementation of our technology would take the equivalent of 300,000 cars off the road each year from a single production site. But what if we were able to produce this elsewhere? That's why currently we recognise that not only should this technology be able to have a positive impact on the UK, but it should be able to do the same thing globally, anywhere where local production of protein is valued, both from a food security angle, but also, more importantly, from a sustainability viewpoint.